so it might be good to. Excellent. So, good afternoon, everybody. As always, I'm Charlie Frick from APL, and with me is my co-chair, Ladrina Chern from Cybereason. Happy to have you at the May Indicator of Behavior Working Group. Today, we're very lucky to have Mr. Harley Parks from Johns Hopkins Applied Physics Lab sharing some information on some work that they've done on a project called MOSAICS that, frankly, I know you guys might be getting tired of hearing me talk about our research for CISA, but Harley's work kind of was the foundation that we've been building a lot of this behavior work on, and really excited about that today. And additionally, we have a few points just to bring up regarding the working group itself. So I might try and just speak on that for a moment. But for those of you that have been participating in the Slack, thank you. Those that have been monitoring the channel might notice that it's gotten a little bit more chatty in the last few weeks, and for all good things. And we're having some really good discussions, especially with Carter, on the nature of different types of behaviors. And I saw Vasilios was chiming in today too, that just mentioning as we move forward, so that not everything's stuck on waiting for once a month on the second Tuesday. We'll keep the conversations going in Slack, but we may also start scheduling a few breakout sessions here and there amongst those who are interested. So I highly recommend, if you're not watching the Slack, to join up and keep an eye on that, because you might find some things that you're very interested in. And we're making some great progress. That's the main update I have at this second, but Ladrina, wanted to give you a chance if there's some things you'd like to handle before we give Harley some time.
Yeah, thank you, Charlie. I think you've covered it. And Kim just asked in chat for the Slack channel info. So if you're already on Slack, it's IOB-WG. And maybe if I can ask D for a hand with a Slack join link, if you get a chance. Hopefully that's a good guidepost.
Perfect. And I was about to, oh, D beat me to it because I was hunting through myself. Perfect. All righty. Anything else, Ladrina?
That's it from me. I think we can turn it over to Harley for the presentation, and then we'll have our second agenda item, just discussing our discussions just after and following.
Perfect. All right. Great. Mr. Parks, it's all yours, sir.
All right. Thank you. I'll share my screen. And just as I go into full screen here, I'm going to have a hard time seeing, I won't be able to see some of the questions if you have them in chat. So Charlie, if I could, ask for your help in monitoring, let me know if there are any questions on that on this, and please feel free to jump in with any questions you have. I'm going to kind of give you a little bit of an overview of what MOSAICS is for those who may not be aware. Then we'll dive in a little bit deeper into a few aspects that I think will be of more interest to this particular group. So again, I'm Harley Parks from APL. I'm and functioned as the technical design lead for an effort called MOSAICS, which is, as it stands for, More Situational Awareness for Industrial Control Systems. So MOSAICS was an effort that was actually funded out of the Department of Navy and Department of Energy to go in and look at how can we improve cybersecurity and cyber situational awareness within these control system environments. And for this particular effort, we're really talking about what we'll term as facility-related control systems. So think of the water, electrical, fuel, building plant automation type of systems. For MOSAICS, we were specifically targeting for this initial deployment against a power distribution system for the Navy at a naval base in San Diego. So that was kind of our target environment where we were going operational with this system. So I like to always talk and kind of talk about the threat. I don't think, this is something I need to belabor for this group. But obviously, as we've seen these threats become more and more pervasive over the last, decade plus, we go back to maybe some of the first ones that really were notable with Stuxnet and Shamoon type of attacks, but I think ones that are even back in the 15-16 timeframe that have kind of come full circle again for us in terms of things like the Ukrainian power grid. But we've also had those type of challenges within our own country, right? When we think about the town of Oldsmar back in the Super Bowl last year, the prior year, where they attacked a water treatment system, right? And actually tried to inject lye into the water and actually poison the system in that town. And of course, we're all very familiar, especially if you're on the East Coast of the US, very familiar with the Colonial Pipeline and what happened with that particular incident. So these threats and focus on security in these environments is a growing area. There's more and more attention being paid to it. And that's really what MOSAICS was trying to do. So as we look at kind of functionally, what were we doing with this particular power system or distribution system? So MOSAICS focuses on these 7 functional areas, everything from being able to detect and analyze anomalies within the system, be able to present that information in a consolidated and concise way to an operator, so they can visualize and kind of make their decisions. And then once they've made their decisions, be able to take mitigation actions against a potential threat, and also all the way through to sharing that information with others. So we're gonna, today I'll mostly be focusing on that detection analysis piece and that sharing. But if you have questions on the other pieces as we go, by all means, please chime in. Below those functions, you see that application of automation and the implementation of smart automation. That was a critical function and really was the reason that APL was brought into the MOSAICS effort in the first place. And I'll talk a bit more about that. Okay, so to look at those functions kind of in an architectural perspective, really MOSAICS deployed and was built on the back of both commercial technologies and some lab developed capabilities. Some they're developed by APL as well as a few of the national labs. So ultimately, what is the important part of MOSAICS is really that functional architecture, right? The components we believe can be replaced and they can be swapped in and out with other different components. And that's actually some of the follow-on work that we're looking at doing with MOSAICS. But in this case, you see we're deploying sensors, or we deployed sensors across the various layers of the control system architecture. So starting with the standard servers and workstations, these were Microsoft products, so fairly straightforward, plenty of capabilities out there to be able to pull in different information from those platforms. But the network layer, we used a specific intrusion detection system that was focused on control system protocols. So Nozomi is one that actually allows you to dig into and do deep packet inspection down into the DNP3 protocol, which was used here, or Modbus or other types of protocols that product supports. And then ultimately we went down even to the serial layer, where we were looking and examining serial traffic and serial messages being sent from a programmable logic controller or relay down to an actual field device as a breaker or a switch of some sort. All that data goes back to a single data repository. For this particular effort, we were just simply using an elk stack. And then we were using the Palo Alto XOR orchestration platform, and I'll talk more about that here in just a second and what we did there. Some of the, you see here, some of the lab developed capabilities with the baseline tool visualization, and then finally, for the purpose of our talk today, something we'll dive into more is the MOSAICS alerts capability. So, not surprising when we're talking about orchestration and SOAR, MOSAICS actually is an effort that came out of some of the work that APL has done over the years in integrated adaptive cyber defense, IACD. So that joint DHS NSA effort really, as many of you know, was helped focus on how do we automate security and cybersecurity within our enterprise networks. Well, MOSAICS was trying to take those same concepts and apply those to these control system environments, understanding that that in some ways there's a lot of similarity, but also there's some things that are that actually make it a little bit more straightforward in being able to detect anomalies in those environments. So, as part of that security orchestration aspect, MOSAICS, we built a series of playbooks, a kind of a hierarchy design that we felt was really extensible. You see the kind of the high level on the left or right hand side here, the high level structure of the playbooks, but ultimately there were somewhere in the neighborhood of about 25 to 30 playbooks that were developed for MOSAICS. Each one of these main playbooks have sub playbooks underneath them that allow us to simply add a new playbook, add a new type of investigation, add a new mitigation action or course of action of some sort, and you can extend this architecture fairly easily. Mostly we were focused on the detection. I won't talk a lot about the mitigation, but it was really the ability to automate certain mitigation actions within the control system environment based on operator's decision to be able to take action. And then share the information out. As you see, we did not do a whole lot with recovery, even though it is part of the architecture for our proof of concept here. We did not implement a lot there. Okay, so as I get into some terminology here, I want to just make sure everybody understands because some of the things that we'll talk about, the language of MOSAICS is a little bit different. And part of that is because it is based on this document called the Advanced Cybersecurity for Industrial Control Systems Tactics, Techniques, and Procedures document, this ACI TTP. And all that really is you can think about that as a document that really just simply lays out for an operator or an analyst what are the type of things that I should be looking for in a control system environment that would allow me to detect the potential adversary activity. How would I investigate that activity? And then based on that investigation, what would be potential mitigation options? So it's designed to be very procedural in nature. So step by step, if this is what I'm finding, this is how I investigate it and walk through it. So because of that, it actually lends itself very well to the implementation of the automation that I just talked about. So give you an example of one of these procedures. So this is a detection procedure. That document laid out about 28 different procedures and anomalous events that it wants you to detect or it suggests you detect. We built out some additional ones, which I'll talk about in a moment. But if you look at the right, if you look at the little diagram, at the top, it refers to an A.2.3 reference, and that is kind of a key reference data point for us. But it talks about a regular process found, right? Looking to understand if I have a new process running on a system, on a server or workstation that has never been seen before. So think of that as these detections as being kind of a behavior within the environment that I would like to detect. And based on that detection, you're going to do certain things to investigate and gather more information. Now, that additional information is highlighted here in the circle, and those are what we call integrity checks in the language of MOSAICS. So all that really means is, based on this anomalous behavior, I'm going to go collect additional information within the system, more low-level technical detail that I can present to an operator to allow them to make a decision on whether this is proper behavior or not. Now, ultimately, as it calls out these detections, and you get into the integrity check procedures, part of the challenge that we had as we go through and we collect all this information is, for each one of these, I'll say, behaviors, that can be that can be represented a very normal behavior within the environment. So we had an aspect of looking to correlate those behaviors together to be able to understand and look at potentially an attack chain. And I'll talk more about that as we get into our alerts overview. That was really the function and the purpose of the MOSAICS alerts. So alerts is, for lack of a better term, it's really just a correlation engine. It was a capability that we developed at APL as we started to look at all these behaviors that we were detecting. And within the MOSAICS architecture, we have about a little over 50 different behaviors that we would look for on a regular basis. So again, it could be something like a new process starting on a box. It could be new communication to network communication or traffic between two machines that has never been seen before. It can also be a new account created or anything like that. So all those different behaviors independently can be absolutely normal activity. So the function of alerts, the MOSAICS alerts, was to correlate those behaviors together. So you could think of that as maybe a representative of a behavior set that would be more indicative of an attack pattern or attack chain. So as we brought all this data from those various sensors at the host, network, and even serial layer, went into our data repository, some of that was representative of just plain old log data, or specific log data that we cared about. Others may be actually an alert coming off of that IDS sensor that I mentioned, looking at some of those ICS protocols. So those alerts were different than what I'll call MOSAICS alerts. So MOSAICS alerts are those correlated events, where I can look across those multiple areas and then provide what I'll call a richer picture to the operator to understand what's actually happening in the environment. Okay, so really here you can see a little bit of the architecture for the alerter, but really it's basically pretty straightforward. It's based on two different things: searches, looking for the data, and labels, which are how do I want to correlate the results of those searches to be able to notify an operator. So here's an example of one of those searches and one of those labels. Now, all these searches are defined in the alerter in a simple configuration file, a basic JSON file, where I define exactly the types of searches I want to look for, how often I want to search for those, and then how do I want to correlate it. So if you look at the example on the right, this goes back to that prior.
Hey, Harley.
Go ahead, Charlie.
We have a question.
Sure.
Abdul had a question. He's curious on how the alerts are correlated. Does the engine use intrusion analysis models or AI, ML, and reasoning to separate alerts coming from different intrusion sets into different chains?
Yeah, so good question. So there is some use of machine learning in some of the actual technologies like Nozomi. One of the things I didn't really talk about much up front is a kind of a concept that's important for MOSAICS is the fact that we're trying to do that we baseline the environment. So what I mean by that is we're actually trying to capture the known good state of the control system environment. So we're collecting a lot of data in terms of from all those various layers, whether it be the host level, the network level, even down to the serial layer. What is the normal operation of those systems? And so that allows us to be able to help identify. And as we query the repository, we look at these anomalies, we can compare it to, in this case, a change process. Well, to be able to detect the change process, you first have to know what was normal, right? What did you expect? So that baselining is a key part of what we do for MOSAICS. And in the case of some of that capability, we are using machine learning to be able to understand what that normal state is and be able to detect those changes. Now, we don't actually correlate anything back to a particular threat. What we're looking for is simply the chain of activity that might be representative of a threat, and it could be any threat. From the perspective of MOSAICS, we weren't very concerned whether this was a nation state or any other threat or anything. We just wanted to know, I have a pattern that's represented. I'm sorry, go ahead, Charlie.
I believe Abdul has a follow-up.
Okay.
Yeah, I can. Thanks, Charles and Harley. I mean, I can speak up if that's good.
Sure.
Awesome. Okay. Yeah. So my question, Harley, I think like you answered pretty much. You answered it pretty much. Was that if if multiple threat actors are operating on your environment simultaneously, and you're getting like alerts from both of them, then would you, like in your chain, would it be like multiple chains like belonging to each of the threats or threat actors, right? And it seems that that's not the case. You would essentially be chaining all of those events up perhaps in a single chain is what it would be, right?
Yes, that's exactly right. We were not trying to necessarily say that this particular chain might result, equates to this particular actor that might be in the environment. And if you had a second actor, that these ones, these particular events were related to that. It would be possible, and certainly part of the maybe an aspect that would need to be improved on in the future is that these, you could mix some of these behaviors up between one actor or another. But ultimately, our goal was to help identify that you have at least an actor of some sort in your environment. And by being able to pull these together and correlate, that ended up, and I'll show some results at the end, ended up being what I think it was a fairly powerful method for doing that.
Got it. Thanks, Harley.
No problem. So anyhow, as you see here, the example on the right, the process. So we're looking for that change process, something new. Again, I will fully acknowledge that in a control system environment, doing that baseline and understanding what's normal compared to, to help you identify what's when you have an anomaly is certainly a bit easier, right? These are not as dynamic environments as an enterprise IT environment. So, that obviously worked to our advantage with MOSAICS. But as you have that, you then, that query, and as you query the system looking for that over a defined period of time, you're then going to associate that with a label. And the label goes back to that original ACI TTP reference, an A.2.3, in this case, if you look at the bottom, of an unusual process detected, right? And in this case, it's only looking for one specific behavior in the environment. So if I detect a process that I've never seen, that shouldn't be there, again, in a more control system, more static control system environment, that's something I would care about. So in this case, I'm not really correlating, right? My search here is I'm just looking for that particular one event, and I'm going to alert based on that. Looking at some other examples, maybe something a little more complex, you see on the left some of the searches that were defined in our configuration file. So, you have the top one, which is simply a I'm going to look for certain Windows event logs. In this case, it might be representative of a lateral movement technique. Or I have a sysmon event that shows that I've created a new file on a box. And then I have a couple of network alerts, maybe a new node or communication with between two boxes I've never communicated before from the network layer. So as I look at those events and those behaviors, of course, any of those can be normal activity. Maybe my baseline was not as robust as I thought. Somebody, maybe an administrator is doing something and creating a new file or reaching out and connecting to a different box. But as I correlate those across and you see the labels, I have the ability to maybe correlate what we saw in that previous example of that first one, a process starting on a box. And the way the syntax works here is that search all means anytime I see multiple things in the search all, think of that as an and condition, as well as between the all and the any is again an and condition, and then the search any is an or, right? So in this case, I would look for a process starting on a box, and I would want to see any one of these, and these just ACC 01 through 04 just represents different types of lateral movement techniques that we'd be looking for. So I'd look for a process starting, and then any one of these lateral movement techniques, those two conditions combined would throw this particular alert, right?
Yeah, Harley, I think you have another question.
Sure, thank you, Charlie.
This is interesting. So just curious as to what you're showing over here. I think this is the elastic query language, right? Is what this is? Okay.
Yep. Yes.
Curious as to if you guys looked into Sigma at all, and perhaps like using Sigma rules to sort of search, because then it sort of like makes you vendor agnostic from a and sort of like loosely couples your code with the storage technologies, right?
Great question. So yes, this is more elastic language. For MOSAICS, we did not look at Sigma, but since MOSAICS, we have looked at Sigma, and we've actually, I've even looked at how we would take some of these queries and convert those into a Sigma language or Sigma structure, so that you would be kind of agnostic of the particular SIEM product you might be using, that type of thing. So we didn't it for the MOSAICS effort, but we have been looking at that subsequently. And Charlie's been, some of the work that Charlie's been doing, as well as another effort that I'm working on, we've been looking at those.
Thanks, Harley.
Sure. Okay, just to kind of take a look at these a little bit more. The second example down on the right, the second label, another version of the lateral movement, but in this case, I'm looking at a network communication. And again, any one of these lateral movement techniques that might hit. And then finally at the bottom is something a little different, where maybe I have a new process that starts, I have a file being dropped, and then I see, so both of those would have to exist. That was an and condition. And then, and one of these network protocols, maybe, or network alerts that have communicating with a new node or something like that. Now, I will point out, and this is an area that Charlie and I have had, considerable amount of discussion about, and that's sequencing of the events and these behaviors. For MOSAICS, we were not sensitive to the sequence of the events. In other words, if you look at the bottom one, I have a file being copied and a process starting. So typically you would think of that as being an adversary drops a new, a piece of malware on a box, file creation, and then that malware executes and I have a new process starting. Well, we were not sensitive to the order of that, because certainly I'm sure we could all sit here and speculate of certain attack change where the process might start, reach out, grab a new piece of malware, and then download that, that file. So we tried not to be sensitive. I think in some cases that worked to our advantage. And I think there are potentially other cases where you would want to be sensitive to the order of how some of these behaviors occurred. But just pointing that out, because I know that's an area that Charlie and I have had a good bit of discussion on. Okay, So that's really how we looked at the detection and correlation. So that behavior and what I'll say those behavioral sets that we were looking for and detecting in MOSAICS. Once we had that information, those alerts I mentioned, they went back to our security orchestrator platform, XOR in this case, and we would do the investigation of those alerts. In other words, going out and running all those integrity checks associated with each one of those alerts and pulling in more data, right? At the end, we provide that to the operator, and we give the operator an option of taking mitigation actions, as well as being able to share that information out with others. So our sharing was, based on an operator-initiated action. They could take all the detailed information of what they did with that alert, package it up, and share it out. And once they initiated it, it was all done in an automated fashion. We used, obviously, we bundled that information up in STIX, and we used, in this case, STIX 2.1. So as I mentioned, operator initiated, we would go in, and then the orchestrator would query the platform for the alert and all the associated technical details associated with alert. What was that reference, that A.2.3, for example, that ACI TTP reference, which in a more standardized way, you might equate back to, a MITRE attack technique, that you may want that to be your reference. But I do believe it's important to have that standard reference of some sort across your community. But for the control system environment, this happened to be what was there at the time. The MITRE attack for ICS had not actually been published. We were just a little bit ahead of that being published formally, so we did not use that. And since this was what the DoD was working off, we went off with that reference. But it would pull that information. It would pull all the sub-elements of what were the behaviors that I saw in the environment that caused this alert to trigger, package that up, as well as all the associated underlying information from those integrity checks. Did I find anything else, any other anomalies in the environment that that might be indicative of or show that I have a potential attack here? Bundle those up in STIX 2.1 and share those out. So looking at the STIX bundle itself, we really use these three objects, right? We use the indicator to talk, and you kind of see the example of that on the right. And this is just a piece of that, that bundle, obviously. But we use the indicator object to share the alert activity. What was the alert? What were the pieces of the alert or the behaviors that triggered that particular alert? We use the course of action object to pull in all the additional information on the indicators. So the results of those integrity checks, that was all placed in a custom course of action object, as well as the mitigation action. So for MOSAICS, we really only had 2 mitigations that were built in because part of our, the focus was we had to keep the system up and running and up and functioning. So the only actions we had were really about network segmentation. We could segment the control system from the rest of the environment so they can still produce power, or we could segment a particular node in the environment from the outside world. So think about it as trying to break that command and control in the environment. So those were the actions. We bundled those up, and of course we linked everything with relationships objects, and that was the way we did it. Now, I would say this was very early work in this area, so I think from the perspective of how we would do that if we were starting today, we might look at things differently, and certainly, if we, as the maturity of this working, or the work in this working group matures, we'd probably go back and take a look at how we did that and maybe drive that in to keep up with some of the more standardized way of doing some of this activity.
And Harley, another question that was going through the chat was, curiosity is whether in MOSAICS, if you're using the attack pattern objects, I believe the answer to that is you weren't then,
We're
but
not then, yes.
and your the follow-on work that you've been working on that has played a key role for.
Correct. Exactly. Yes. At this time, we did not. And I'll be honest with you, we were doing the sharing piece of this as a proof that, you can properly bundle this type of information get it to people. But the unfortunate part is there was really within the control system environment, there's no architecture of ways to share this, right? There's no back-end infrastructure to share these bundles. So we were really producing the bundles, putting them on a file share, and that's kind of where it ended. So you think about it, we have a dangly wire in these kind of environments. And frankly, the department needs to build that structure out for control system environments, similar to what it is for more enterprise networks. But yeah, a lot of work I think needs to be done in this area for the sharing. But it was showing at least you could do the concept that you can do this, you can pull it together. And what I'll show here were kind of the results of, what I think.
I believe there's also another follow-up question.
Sure. Okay.
Yeah, just a follow-up question on my last one on attack pattern, the STIX attack pattern object usage. So are you guys looking into, let's say, like using that attack pattern so that you can package your Sigma rules and your elastic queries within the STIX, like within the STIX schema itself, and then use your threat intelligence platform to basically sync up all the various elastic rules and Sigma rules that you might have with your detections pipeline to be able to do detections actually.
Yes. So with our follow-on work that I alluded to earlier, yes, we are exactly looking at that, looking at those attack patterns, how you may use a detection object or something similar to that, that you would be able to put that Sigma rule in and be able to share that out. So you would have the detection associated with the behavior, but then also be able to, look at the relationships of how you would want to correlate those behaviors for new types of activities and be able to share that. So we're looking at that in some of the work we're doing now. It was not done during MOSAICS as this ended a little while back.
Sounds good. Thanks, Harley.
Okay. So, I wanted to kind of, I think this might be my last slide, but I wanted to kind of highlight this because I think this was pretty powerful when you look at the results of our testing event. When we deployed the system out to this the power distribution environment in San Diego, we had a red team. It was actually out of Sandia National Labs. As we deployed it, we baselined, we were monitoring over 3,000 nodes on this network, and a simulated part of their control system because there was obviously some concern about actively attacking their operational system, but it was all part of their operational system. But we were limited to where we could go after the attacks. But Sandia initiated 17 attacks against that control system and the network, and all the way from the supervisory layer down to specific low-level attacks against those PLCs and field devices. And because we were looking for behaviors, not specific signatures, not any particular identified pattern in traffic, we were looking for the behaviors. We identified and were able to see all 17 of those attacks, sometimes in multiple ways, right? Because as I mentioned, we might correlate and alert on one part of the attack chain, and then later we would correlate and see other parts of the attack chain and alert on that. So we actually had a 100% success rate of identifying their attacks as they went in and challenged us through that. We also had another event that occurred where a contractor, the site, or at least the folks we were working with at the site, were not aware that a contractor was coming on base and installing some new components. And we actually detected and alerted on that new traffic and new aspects of the system being introduced. So it was a really nice, I'll say, additional real world example of the detection and the events that we had. So, and with that, I think that's everything I had, but I'm happy to entertain additional questions.
So Harley, one question is this slide deck available for sharing?
Yes, everything we have here has been shared previously, publicly released. So yeah, absolutely, we can share that.
All right.
Harley, thank you so much for presenting. You know, and one question I have is, it seems fairly straightforward for the operators using the system to be constantly, you know, doing some care and feeding of the system and tweaking it to their needs. Are you still developing new alerts and getting these ready to push out in different environments, or is everything somewhat baked from this scenario that you shared from last year?
So we're not, we APL are not, right? Basically, the system was turned over to a Navy element in Port Hueneme, California, who is responsible for kind of the care and feeding of this. So, you know, the one thing I don't think I touched on during this is because the alerts, you know, if you have the data sources, and of course, everything starts with having the right sensors and the right data. But if you have that, adding a new alert to the system, or even taking something that might be a fairly generic alert and making it very specific, is nothing more than changing that config file with a new search and maybe a new label, or adding a search to that label, an existing label. So updating that was very straightforward. We actually did that during the test on the fly, because we saw some things we wanted to understand better, and we were able to change some of that and generate those alerts. So yeah, so we're not, but it is being maintained by others. Now, one thing I'm really interested in with follow-on work is if others outside of that Navy element were sharing new ways of detecting things, is there a nice, clean, almost, you know, an automated way of being able to pull that information in through those STIX bundles, sharing those behaviors, sharing those detection objects, and introducing it into the environment. So that's kind of some of the follow-on work we're focused on now.
All right. Do we have any other questions for Harley? I will take silence as consensus. Thank you again, Harley. And also thank you, Abdul, for your questions, because I think a lot of that tied into, you know, those were a lot of the same questions we were asking ourselves as we went through that project, and things that we're looking for in parts of the new offerings on indicators behavior, and also looking to merge that with some of the other ideas that we're having on the channel right now, which